In this video, we're going to look at arc length. Arc length is a very easy way for us to discuss the length of an arc on a circle. Clearly, it's the name of arc length. But basically, I want you guys to think about that. It's like finding a piece of the circumference. So if I'm looking over here at the orange piece, I'm just finding this particular section. That's our arc length. So we're going to focus on utilizing this formula of S equals R times theta. S is going to be your arc length, R is going to be your radius, and then theta has to be your angle in radians. It's not going to work if you try to do it in degrees. So make sure that you convert your angle to radians for this. All right, so let's look at our first example. So in this example, they want us to find the arc length. The arc length is the dotted blue line there, and they give us our radius, which equals 3. They give us our theta, which equals 4 pi over 3. And so we're going to utilize that formula of S equals R times theta. So my arc length is going to be my radius times my theta. So go ahead and simplify this. We get arc length equals 12 pi over 3, which is going to simplify and give us our arc length of 4 pi. And that's it. It's as easy and as simple as that. That means that this dotted blue line that I'm now going to change to be orange has a length of 4 pi. All right, let's look at another example. Sometimes you may be given the question where they say, hey, I'm giving you your arc length. I want you to find radius, or I want you to find theta. If that's the case, we're still utilizing arc length equals radius times theta. And I just want to follow the same principles so that I can get whatever variable we're looking for. So this particular example, they give us our arc length, which is 32 pi, and they give us our theta, which is in radians. So I want to clean this up a little bit, so I'm going to rewrite it as 32 pi equals, I know that that's technically radius over 1 times 2 pi over 3. So when I do that, I can say 2 pi r over 3. And we'll go ahead and start simplifying. I'm going to multiply both sides by 3. That's going to give me 96 pi equals 2 pi r. Well, I want to get my radius, so I'm going to divide both sides by 2 pi. Well, I know the pi's are going to cancel here, and then 96 divided by 2 gives me 48. And that is my radius. So again, just utilizing my arc length formula here, this is a very easy way for us to find them. And it's always going to be a very easy process once you master finding the radius or theta till you find the arc length. So look at this final question here. This one is a little bit different. We want to find the arc length. Find the length of the arc that has been intercepted by a central angle of 120 degrees. Well, if we have this angle that is right here at about 120 degrees on a circle whose radius is 5, they want us to find this length here. So again, we have S equals R times theta. So I'm trying to find S, my radius is 5, but I've got to have radians. So in order to have radians, what I need to do is I've got to convert 120 degrees into radians. And the way that we do that, if you haven't watched my video on converting from radians to degrees and degrees to radians, go check that out. But it's a very simple process. 120 degrees, and we're going to multiply that by pi over 180. We know that this is always over a 1, so we simplify and we get 120 pi over 180. Simplify that down as much as you can. We can factor out a 60 from both of those, and we're going to get 2 pi over 3. So now we can actually run our problem utilizing 2 pi over 3. So we get s equals 10 pi over 3. We can't simplify that anymore. So our arc length there is 10 pi divided by 3. So again, I hope this video helped you understand arc length and the simple procedure used to find it. Just to make sure that if you're finding your arc length, you're given your radius and you're given your angle measurement, your theta, in terms of in radians. So thanks for checking out the video. I hope it helps. I'll see you guys next time.